Welcome. Welcome to our new series of lectures regarding photovoltaic system design series. I'm hoping during this series, I'm really hoping to share all my experience in photovoltaics, and I'm hoping at the end of this series, every single person should be able to completely design a residential project for a grid-connected PV system, for hybrid grid-connected PV system, for a standalone PV system, for a commercial project, for a grid-connected system without a generator, with hybrid PV system with a generator, if a residential project using a grid connected system, or using a generator to support their system. And then I want to introduce a commercial project. I want to introduce a commercial project where you guys can actually, for a small committee or community, you can design a special project to advance your financial and electricity step. And then for a PV farm. At the end, for every single case studies, I am going to include a financial module regarding the system. And I'm really hoping that you guys will all gain some real benefit from this setup. Today, we are going to start part 1. This lecture contains brief introduction to renewable energy sources. What are the available renewable energy sources that we can use? What's a photovoltaic system? A quick introduction. Remember, this series doesn't include the chemical information behind the solar cell. How does the solar cell operate? How's the sun energy? What's the amount of sun energy required? What's the joule of the sun energy required to move the photon? It's only what's a PV solar system in a brief introductions. Why PV system? Why PV system is the most suitable for residential property? Why? There must be a reason why, for example, not wind. Why not, for example, biomass? And then, this is very important, the electric power consumption assessment. For some of you who doesn't have an electrical engineering background, I want to give 2 or 3 slides. How do you guys do an assessment? How do you guys do an assessment for the electric consumption? You need to be able to determine the required energy, electric energy, required for the house, for you to design the system that suits. And then I want to go in details about photovoltaic system types. There is a multiple types. Grid connected with energy storage, without energy storage, a grid connected, no injections, standalone. We're going to go through each one of them step by step. And then we are going to go through residential PV system components. We're not going to go in this section, in this lecture, into the design element. And then we are going to go to residential PV system connection components. So when you want to connect, what are the components required for your system? That's what we're going to cover. And then high-level cost per items. The high-level cost per item will be included. Let's start. Introductions. What's a renewable energy? The definition of the renewable energy is the renewable energy that does not deplete with time. What are they? What are the renewable energy sources? I have solar. Guys, we need sun. We need the solar sun for us to survive. If we don't have solar, we cannot survive. That's number one. Wind. Wind. We need to sustain wind on our planet for us to survive. So solar and wind doesn't deplete. They're always there as long life is there. After our life, after the life end on this planet, maybe things differently happen. But now I need the solar and I need the wind. Biomass. What's a biomass? Biomass, basically, it's all our waste from food, from trees, from timber, from all other stuff, animal waste. Geothermal. Geothermal, our underground system has a heat sources that we can use. Ocean energy. Have you ever, a year, 365 days a year, when I go on drive along our oceans, we always have waves. Very rare, maybe a few days a year on the shore, you will have steady waves. However, most of the time, you'll have waves. Hydro energy. This always exists, the cycle. So as you can see, this energy, these sources, always there, will never deplete. Ocean will never stop the waves. Hydro, always there. Geothermal, always there. Biomass, our waste of our food, of the animal waste, of the farmer's waste, sun and wind. These are always there. These are the main renewable energy sources. Photovoltaics. As we said before, we are going to focus in this lecture series for the solar. We're going to give one slide to introduce what's a solar system. Photovoltaic technology is the ability to convert the sunlight, into electric energy to support the required load. So what do I have to do now is, I need to design my system, my photovoltaic system, to support my electric load. That's my aim of this system. So PV solar system take the sun energy, convert the sun energy into electric power to support the electric load. Why solar system? Why the solar system? Why not the other types? Wind. Why not the hydro, for example? Why not the ocean? Why not the biomass, the geothermal? Okay. Can you guys install a big wind turbine on your house? No. It's number one, noisy, could be noisy. Number two, required a strong support. Geomath. No one can drill to go down to the heat section of our earth. No one lives inside the ocean. The biomass. No one can produce sufficient amount of waste to support. Also, except the PV solar system, all of them require a big infrastructure. Except the solar system, you will see, you can embed this infrastructure within your house without noticing. This is a figure shows the solar farm. This is another figure, shows the solar farm. Okay, great. What can I conclude from these two figures? From these two figures, I can conclude two main elements. I need an infrastructure. I need the infrastructure to install my solar panels. And number two is, I need a big land to support my solar panels. These two. Great. This presentation was delivered by Mr. Ty Christopher to one of the courses I attended maybe a few years back, 10 years back. He showed the two pictures for Berkeley area, which is in Sydney. This was in 1997-2005. See this area? Imagine I want to install solar system. I have to go disturb the ground, put the infrastructure to put the solar system. Look the houses. Houses is there already. See, when I put the houses, I put the infrastructure. This is Berkeley area. This is Northwest in Sydney area. Same year, look, the development. The advanced development of a human when it comes to infrastructure, housing or building, offer the infrastructure to install your solar system, your PV solar system. This is the sustainable city in Dubai. Can you see? Either I go ahead and I install an infrastructure for the solar in the desert, or I put it on top of the houses. The houses offer a free. The house offer a free infrastructure for your solar system. That's number one. Number two is the house is the actual load. If you followed my channel and you listened to the power system lecture, the generations go through the transmission to take for the load. So I need the load to consume the generated power. If I have a solar farm far away, I generate the power and then I transmit the power to the load using transmission network or distribution network to get to here. Hold on a second. How about I install the solar system on the house? I install the solar system on the house where the load is. That's a node of the load. So I don't have to worry about the transmission line. I will reduce the amount of losses on my transmission line network, and straight away I install it at the node. So why PV system on the house? Because the house already provides a free infrastructure for it. Number two is PV system is very silent, no noise. You won't even notice that it's there. If you use a BIPV as well, it will advance your house standard from a sustainability. And at the same time, it offers the power at the node of the load. Is that clear why PV solar system now? It's critical, it's the most important for residential property. What's the electric demand? For those who don't have an electrical background, I need to introduce two types of power called rated power, which is the electric rated power, is the maximum allowed power, can be taken from a generator if rated, or can be absorbed by a apparatus, an electric equipment. If I give an electric equipment beyond its rated power, I damage it. The electric rated power unit is kilowatt. This is one type, rated power, or also known as instantaneous power. This is the instantaneous power could be as well. And then I have electric energy consumption, which is the actual energy consumed by the appliance. It's the actual energy, the actual consumed by the appliance, and the unit is kilowatt hour, megawatt hour, gigawatt hour, depending on the scale. Maybe the utility will use gigawatt hour, terawatt hours. For our house, we use kilowatt hours because we small consumption. Now, let's put some equation for those who don't have the experience in electrical engineering. Let's put some equation. Okay. I have P instantaneous equal to, for example, 2 kilowatt, 20 kilowatt. If this power is running for example, I have 20 kilowatt for 2 hours, your consumption P in kilowatt hours, it's equal to 20 kilowatt times 2 hours, which gives you 40 kilowatt hours. This is known the energy consumption. This is known as the energy consumption. So, to summarize this, I have the energy consumption. I want to put P consumption. It's equal to the actual power, instantaneous power, the actual power absorbed, power, multiplied by the time. What do I mean by the actual instantaneous power and multiplied by the time? The actual instantaneous power multiplied by time will give me the kilowatt hours energy consumptions. Let's say, for example, I have a dishwashing machine. The dishwashing machine, I have a dishwasher machine. So let's call it DW. I have a dishwasher rated at 2 kilowatt. Every cycle of the washing will take me 2 hours. The question is this dishwasher running for 2 hours at 2 kilowatt? The answer is no. It will vary. So let's assume this during these 2 hours, this is my 2 hours. This is 0, hour 1, hour 2. For example, at the beginning, for half an hour, the consumption, this is B, the consumption was 0.5. And then between 0.5 to 1, let's assume it went up to 1 kilowatt. Between this one and 1.25, it went up to 2. And then it drops down until 1.5 and then goes down like this. This is 1, this is 2 kilowatt. So guys, how I determine my consumptions? My energy consumption, guys pay attention, my energy consumption, the kilowatt hours, it's equal to this time multiplied by this power, equal to 0.5 multiplied by 0.5 plus this period, which is 0.5 times 1 kilowatt, plus this period, 0.25, each one of them, multiplied by 2. Let's actually put them on the side bigger. So now I have the power consumption, it's equal to 0.5 multiplied by 0.5. This will reflect of this area, plus 0.5 multiplied by 1. This is the 0.5 multiplied by the 1, plus 0.25 multiplied by 2, which is this, plus this is 0.25 multiplied by 1, plus 0.25 multiplied by 1, plus 0.5 multiplied by 0.5. Is that clear? That's how. So, this 2 kilowatt represent the rated power, the maximum power that can take. However, the consumption, as you can see, it's way less. The 2 kilowatt is not running for 2 hours. That's why, if you have a dishwasher or a washing machine the actual manufacturer, it will state for you the consumption per cycle, kilowatt hour per cycle, and also you can test this. You can put a monitor and it will show you per cycle how does it operate, and you can log in this operation. Is that clear? This information for those who don't have an electrical background. So it's a very important to distinguish between the instantaneous power and the consumption power. Let's continue our presentations. Give you one more example. For example, another example, I have a 3 kilowatt generator supplying a 1200 watt motor, water pump, for example. I have the motor is running for 2 hours at rated power. The motor running for 2 hours at rated power. Because now I set a rated power this. So now I have the power consumption is 2 multiplied by 1200. Because now it's running for 2 hours at rated power. So see, a generator running for 2 hours, rated at 2 kilowatt, it gave me 2400. It didn't give me 6 kilowatt output. Because the consumption only I'm taking out of it is 2400. So the generator could give you 2.5 kilowatt output. Let's assume there's a 0.1 kilowatt hour losses. Is that clear? So it doesn't mean if I have a generator, 3 kilowatt, running for 2 hours, doesn't mean the output of the generator is 6 kilowatt hours. No. Depending on your connected load. And your connected load, depending, is it running at a full rated power or not? We can do the same for all the house appliances. We can do the same for all the house appliances to establish our load. For example, every single hour of the day, what will be on, what will be off. And depending on what's on and what's off will determine my system. Throughout our series, we will discuss regarding available energy management tool to govern this process. Because this process could change. I can change it. I can, for example, push the oven from this point to this point, cooktop from this point to this point. I can organize it. I can manage my way. It's up to me. It is up to me. How do I manage my consumptions? Now, what are the residential types? What are the residential photovoltaic types? I have a grid connected system. I have a grid connected with energy storage. I have a grid connected with no injection, which is we're going to discuss each time. We have a grid connected with no energy storage and no injection. And we have off-grid system. These are the systems that we are going to capture. If someone want to be more innovative, I can say hybrid system with wind energy, like this picture. I can say wind energy plus energy storage plus photovoltaic plus diesel generator plus grid. But I want to discuss, I want to give you this, during the series, we will learn how to design each element, do detailed design, detailed installation, detailed commissioning, and cost analysis. Number one, grid connected. What's a grid connected made of? It's made of solar panels, inverter, connected to the grid both ways. So what does this system allow me to do? This system, the generated power, can give to the house or to the grid, can take and give from the grid. That's known as a grid connected system. This grid connected system requires the power 24 hours from the grid. If the power cut off from the grid, you cannot give the grid. Because you cannot, it's so small, your system, it will turn off. So that's why, if you want to have a standard grid connected system for your house, you should have always power in here or some system to switch off. And your relay should be able to start on its own without the grid power. Hybrid grid connected system. I have the grid connected system and plus I install a energy storage. The system, some of them, like any other devices, I can take the surplus energy, I can take the energy, use it for the house, the surplus will go into the battery will use peak hours. Why I use this system, for example? During peak hours in some countries, the actual energy cost, the electricity cost, it's way higher than, for example, overnight. So I use the energy of the battery during peak hours to save on the cost. So I have the house supported by the sun, which is this. I have the house supported by the battery and the grid. Now, hybrid grid connection, no injection. Look guys, notice, the system in here is have the solar panels, have the house, the inverter feeding the house and the battery, but from the grid I only take or never give to the grid. I never give to the grid. This, I can see this example is perfect, for example, for Lebanon, where there's a regular power outages. For example, area where there's a regular power outages, like this, or area where I have a diesel generator. Instead of the grid, I have a diesel generator. I don't want to feed the diesel generator. Diesel generator, I use it only to support me when it's needed. I have a grid system, no batteries. So look, I have a system where I solar, I don't have an energy storage, I have only grid or a generator support the house. This is known as a PV grid connected system, no injection, no batteries. Off-grid system. The off-grid system, I have no grid connection. I could have a diesel generator if I wanted to, but I want to have it as a completely off-grid, rely only on solar system. Inverter, hybrid inverter, charger controller, battery, and your house consumptions. I want to focus on Lebanon country. These are suitable for Lebanon. These are the three systems. When you have a power outage, you have to be careful. Do not feed to the grid, because when it turned off, if you don't have the proper protection, you will damage your system, your grid. And also, large number of grid connected inverters, they don't have the self capability to start without having the grid connection. Critical components. What are the critical components of my system? I have my inverters, charger controllers and inverters, hybrid inverters. I have my energy storage. I have my metering system or smart brain to control the power flow between the battery, the solar, the house, and the grid, or in the case of diesel generators, and so on. Whenever you want to go ahead and buy a hybrid inverter or a grid-connected inverter or a standalone inverter, make sure you will have the MPPT algorithm. Try to avoid to use pulse width modulation, PMW. Try to avoid it because the MPPT is proven to have higher output. It will harvest more sun. Control the energy distribution. Whenever you want to go ahead and buy a system, you need to make sure that this system has the ability to control the power source to the load. So this system has the ability. Where do I take? Do I take this priority first, then this second, then this third? Or I choose, for example, I want this only to be nighttime, for example. So I need to have the ability to control the power source for my house. Control the charging source. For example, I need this system to only be powered from my PV solar system. Or do you need it also to be powered from the grid as well? You want to charge your battery using only solar or also grid? Control the time and the power. So what time you want to take from the grid? what time you want to get from the grid. Like I said to you guys, I want to try to minimize, in some countries, I want to try to minimize the power injected from the grid to my house during peak hours where the cost is very high. Maximize the sun energy usage. So I need to be able to maximize this by having MPPT. So when I have a maximum sun, I need to take this as a first priority. So I need to utilize the maximum sun of my system. Expand the life of the battery. This system, this hybrid, should have a control mechanism. So do not overcharge, do not undercharge your system. Do not empty your battery, make it dry. You don't want to damage it. You need to be able, like I said, to manage your electricity bill by reducing the amount of energy injected from the grid or taken from the grid during peak hours or high period cost. This is the battery. Protect the battery is very important, guys. When you go ahead and purchase your hybrid inverter, you should have a overcharge and over discharge control mechanism within your system. It's very important, very, very important. Temperature and ventilations. Please try to avoid put your, especially the lead acid battery, the AGM, the gel, put them in a place where they get heated and there's no ventilations. Otherwise, it could cause to a major damage and could lead to a fire. Solar panels. Guys, there is multiple types of solar panels. I want to talk about two main types. Type 1 is the monocrystalline cell, and the type 2 is the polycrystalline cell. What's the difference between mono and poly? Mono is used from purely silicon. So the wafer is made from purely silicon. That's it. Looks like this, and usually it's black color. It has higher efficiency than the poly. The poly is used by mixing multiple types of silicon material together to form the wafer. The wafer are this small section that you see. And nowadays, because of the technology, you have all type of arrangement, all type of colors when it comes to solar panels. The batteries. What type of batteries do you guys have available? You have lead acid, you have AGM, absorbed glass mat, you have a gel, and lithium-ion. Now, lithium-ion is one of the most advanced ones so far, however, it costs a lot of money. Lead acid could be the cheapest one. What's the difference between AGM and a gel? Gel could last longer, have a longer life. However, gel could not stand high current pressure. Gel is better because it can withstand high current pressure. For example, you're running a small motor. You could have a small motor with inrush current. So what will happen is the AGM is better for you than the gel. That's why the AGM, they are selling way faster, way more than the gel. Supporting structures. For your system, you need supporting structures. Depending on your location, some of them has to be like this. You need the inverters like we discussed. The wiring system is very important, guys. You need to put the wiring system to avoid damage, and you need your batteries. This is the complete system for your house. The last section we are going to talk is about product cost. Currently, the solar panels cost between 31 cents to 5 to 50 cents per watt. Standard one. Your inverter could be between 20 cents to 70 cents per watt. Some inverters are very high tech, could be more expensive. Some panels could be a little bit more expensive. I'm talking here about a standardized system. The batteries could be between $1.4 to $2.34 per amp hours. The battery is rated, for example, 12 volt, 200 amp hours, 250 amp hours, for example. For the wind turbine, if you're interested in a wind turbine, the cost is about $180 to $260 per ampere, each amp. And the structure is depend on your locations. Is it easy? Is it hard to get to? Also the wiring depending on the location. applications. I hope this lecture gave you a brief introduction on what's a solar system, what type of solar system are available, and start thinking which one is suitable for you. Grid connected, no grid connected. Do I take from the grid? Do I have a power from the grid all the time? If it's no, I don't want to inject to the grid. I want to store the energy. No. During the second part, which will come soon, we will talk about the detailed design for residential PV system. So please tune to our next lecture where we are going to go into the detailed design for a grid connected with energy storage. I want to show you how to determine your component characteristics. Which inverter do you choose? For example, I want to go for a grid connected with energy storage. Which inverter to choose? What sort of characteristic I need to look for in my inverter to design my system for optimum use? System layout and connections. For example, what's the number of PV panels? How many PV panels I need? 100, for example? How many in series? How many in parallel? How to connect them together? You know, what's the maximum voltage I should achieve during midday? What's the maximum voltage I should achieve during early morning, late evening? Required energy management system. I want to introduce this element for you to show you there is a lot of tools that also they are cheap that will help to extend the lifetime of your system and reduce your electricity bill and optimize your PV solar system. How to commission the system. What to do to make sure that the commissioning occur in a perfect way and avoid any damage to your system or to your appliances at home. Maintenance requirement. Is there any maintenance requirement? What if they are? What are? What's the cost for it? How do I establish a perfect maintenance plan to suit my system? At the end, we will also include a high-level cost return on investment for this. Part 3, we'll discuss the other types. Part 4, Part 5, as we go. I really hope that this series of PV solar systems, education series, will help each one of you. If you are an electrical background, a manager background, a technician, even from a different discipline, will help you to understand the type of PV system available for your residential properties. And as we go for a bigger system. Thank you very much for listening, and inshallah, I will see you all soon.